sharing part dimensions information and its impact on design tolerances in fixed bin selective assembly by Torian, Claudy, and W.C. Benton. This paper was first published in 2021 by Production and Operations Management. The motivation for the research was based on a typical high-precision manufacturing environment, such as the automotive parts environment, the aeronautical systems environment, and also motorcycle parts. Selective assembly is heavily used in many manufacturing environments. Selective assembly is a cost-effective approach for reducing the overall variation between two or more parts, thus improving the quality of the ultimate assembled product or system that's being produced. The research context. Well, an open question is how much of an impact knowledge about the dimensional mean versus the dimensional variance have on making adjustments in the assembly process. We developed a Bayesian prediction model using parameters from a US-based assembler. One of the products from that assembler is listed below. There were many significant managerial implications of this study. The first one is shared information by an external supplier about the dimensions of shipped component parts can significantly decrease surplus components and also reduce assembly costs. And we chose to look at the dimensional variance first to see if we could estimate it in an accurate way. Our prediction-based adjustments from the historical data yielded comparable assembly efficiency to those made with information shared about the dimensional variances of actual shipped parts. Secondly, we looked at the dimensional mean. Our prediction-based adjustments made from historical data yielded comparable assembly efficiency to those made with information shared about not only the mean, but both the dimensional mean and the variance, which is of the actual shipped parts. The shared information had a larger effect on the assembly efficiency than design tolerance modification. Of course, if things are not fitting properly, we have to change the process and design for modification. But if we can get shared information, we are able to reduce the cost of the tolerance modification. Our study advances the understanding of shared information and tolerance design in the supply chain for selective assembly. Contrary to convention, looser tolerances may be required to increase selective assembly efficiency. And finally, external suppliers are not always willing to or required to share this sort of information. So we have produced a method of predicting whether the efficiency from the historical data could be used for this particular process. The decision maker could also use our model to come up with a way to decide whether it's a cost benefit or not, to incentivize the supplier. Finally, when we get to the acknowledgements, we would like to first thank the managers at the unnamed U.S. middle market manufacturer Bayesian for their inputs and their comments and the use of their parameters. Secondly, we would also like to thank the quality engineers at the Honda engine plant in Anna, Ohio, who provided insight and important feedback on fixed bin selective assembly operations. And finally, the research was partially supported by a grant from the National Center for Middle Markets at the Ohio State University Fisher College of Business. Thank you for allowing us to present our results.